In this lesson, we'll look at inserting and updating an SQLite database in the Corona SDK. I've scripted an application that allows for the value of each icon to be incremented or decremented. With each change, the application's database is updated. If the application is reloaded, the previously stored values are loaded for the user to see. These values can then be changed and updated. Let's get started. Using the Firefox SQLite Manager, we'll go ahead and load a shell of a database that I've already created. So it's this file db SQLite. I'll open it. And it's a very simple database that has no entries. It consists of one table called icons. And this table has 3 columns, an ID column, a name column, and a value column. What we'll be doing is, the first time the application loads, we will be taking this database as a template and we're going to copy it to the application's document directory. The reason we need to do this is because we want to write and update the database in our application, and we can't do that with the database residing in the resources directory, which is typically where our files reside. So if we want to have any kind of write privileges to any type of file, it needs to reside in either the application's document directory or the application's temporary directory, which we're not going to use. So the question becomes, where is the application's documents directory? Do we have to create a directory called documents and place it in the resources folder? The answer to that is definitely no. With any project open in the Corona SDK, head to the File menu and choose Show Project Sandbox. What you'll get is a listing of all the Corona SDK projects you've ever rendered. And highlighted is the sandbox for the current project. We'll double-click that and you'll notice there are 2 folders. There's a Documents folder and a folder TMP, or a temporary folder. So this folder here, Documents, is the Documents folder for your project. What we're going to do is we're going to script a copy-paste procedure in our project so that when the project first runs, it'll take the shell database from the resources folder and copy it into the Documents folder. Once it's in the Documents folder, then the application will just read from that folder. The benefit here is that we can create a clean database and then use that from scratch. And as well, we could conceivably script a routine that would delete the database and copy a new one, but we're not going to do that. So before we get started coding the database features, let's review the code that we have in place that's rendering the icons to the screen. Feel free to stop the movie at any time to look at the code and copy it down. At the top, we have our ever-present constants for width and height of the display. And as well, I've created 2 methods for the creation of visual objects. The first is a label, and it's a very straightforward kind of constructor for a label. And the next is a more complicated method called new icon, which is rendering the icons on the screen. This method we're going to work with a lot, so you do want to take a moment to definitely stop the movie, copy down the code, and get all of the lines, and be sure to trace the lines here on the left-hand side. Okay, and then at the bottom of the code, we have a method called go, which is going to run at the start of the program. And what we're doing here is we're instantiating some new objects using those constructors that we just took a look at. And we have 3 labels. And what I'm doing with the icons is I'm creating a table that has the icon data, and here it's called icon data. And I'm putting the pertinent information for the icons in this table, and then I'm running through that table with a for loop to create the new icons, which here you can see the constructor new icon. So essentially what's happening is the image portion is loaded from the image property of the entry. The name is imported from the name property, count, x, y. Anyhow, you get the picture. If you're curious about the math for the positioning, I basically, for the x, divide the screen into 4, and then multiply by the position I want the image to be at. So if you can think about the screen being divided into 4 equal sections, you can position equally across the screen if you multiply by the section you want the object to be at. Give it a try. It's my preferred method for positioning objects on screen. I don't like to use absolute values since obviously there are different screen resolutions for mobile devices. The last bit of code that we have is a calling of the go method. And of course we need to call that method or else we won't have anything happen on the device. So now we'll take a look at it in the simulator. And here it is, very simple. We have 4 of these icons. These are the labels up here. And if you're curious to know how the plus and minus icons work, take a look at the code for the icon objects. We're going to be working with it here in a minute. So now it's time to code the database portion of our application. The first thing we'll do is we will import the SQLite 3 library. Next, we're going to create the code that will look for the database within the documents directory, and if it's not there, we'll copy the database shell from the resources directory. I'll be doing lots of copy-paste because if I actually were to type this out in real time, it would take a really long time. So I'll copy-paste and explain as I go along. All right, first we'll create code that will look for the database in the documents directory. So I'll go through this line by line. With this line here, local path equals, what we're doing is we're creating a path variable that is a path to our database within the documents directory, not the resource directory. The idea there is that we'll look for the database within the documents directory. If it's not there, then we're going to follow up. I'm using this variable file to actually open this path. So notice the first argument here is the file to open. And then I'm creating a forward reference for our database, just setting a variable db. The next thing we'll do is we'll create a method to load that will initialize the database. Within this function dbinit, I'm checking for file to be nil. If I try to open this path and the file doesn't exist, then file will be nil. That means that the database is not in the documents directory. So in case that is true, then what I need to do is I need to copy the database shell from resources to the documents. So what I do is I create a variable called path source that represents the database in the resources directory, and I open that. Then I need to actually read the contents of the file. So opening it doesn't necessarily mean that you're reading it. So what I do here is I create this variable called contents source, and using the method read off of the file source object, I read its contents. And notice that these particular arguments are specific to these methods, so you can't leave them out. Then what I need to do is I need to create a new file. So I create a variable called path destination that represents this new file, db_sqlite, in the documents directory. So same procedure as before, I'm going to open this file, and then I'm going to write to that file. And what I'm doing is I'm writing the contents that I read earlier. Once I'm done writing, then I can use IO_close to close the source and the destination. I've set 2 different print commands here so that I can have some visual feedback in the terminal. Now, if file is not nil, then it's going to jump to this last portion here in the else condition, and we're simply going to get a printout that the database is present and we don't need to copy it. So now we need to initialize the database and open it in the go method. So here at the top of the go method, I will initialize the database. So I'll call dbinit, and then I'll open it. So that db variable that I set as a forward reference, I'm calling it here, and then I'm using the command SQLite open path. Now that path reference comes from line 10 here, because now by the time we get to that line, there is a database in the documents directory. Okay, so let's take a look at it in the simulator. What should happen is the first time we load it, we'll look at the terminal and we should get feedback that says the database was copied. Okay, let's bring up the terminal. We'll reload it. And you can see here, database not present copying, database copy done. And if I reload it again, then you see database present, no copy necessary. And if you want to actually see this happen on the fly, what we'll do is we will load the project sandbox, and we will go to the Documents folder and delete the SQLite database, and watch here this Documents window. As I reload, you can see it actually copying the contents over. It's pretty cool. If you wanted to read this from the Firefox Manager, I just advise that you copy it from this Documents directory to your desktop. Don't actually try and find this sandbox on your computer. I just think it's a waste of time. You can copy it over to a location where you know it exists and then open and look at it. Now we need to create methods for loading entries or inserting or updating entries in the database. First, we'll create a method to load entries. So after the db_init method, but before the label method, I'll paste the following code. And so here we have db_load_entry name. So let's go over the code. The local variable SQL, and that's not to be confused with the SQL variable that's outside of this function scope, is a SQL statement. So select value, so that's the value column, from icons, that's the icons table, where name equals, and then name is being passed from the method. So select the value column from the icons table where the name entry equals, and then whatever name is. We're going to go ahead and print the SQL variable so we can see it in the terminal. And then we're going to traverse the rows. We went over this in the read tutorial. And we're going to return the row value because it's only going to select one row. If we had multiple rows, then we would create a table and return that table. But this will only return one row. Okay, the idea here is going to be that we're going to load the values from the database into the icon objects. So now we'll go into the new icon constructor and implement this particular code. So let's scroll down into the new icon constructor, and we will find the line g.value equals 0. So instead of that line, we're instead going to use this line. g.value equals, and then we're going to call the db_load_entry method and pass the name. And if this is true, then we're going to use the value returned. Otherwise, we'll use 0. Remember that if the row doesn't exist, we're going to get nil. So if we get nil, we'll use 0. Otherwise, we'll use the value. And we'll save that. And right now, we've only copied the database over. We haven't actually created any new entries, but let's go ahead and test this out incrementally so that way we don't get too far in the code and then find that it doesn't work. So head back to the simulator and refresh the screen. And you can see now that I'm printing the SQL statements, and this is what it looks like. Select value from icons where name equals and the name of the icon. One thing you really want to be careful with when you're working with SQL statements, notice that I've got these single quotes. I'll show you in the code where that exists. Right here before the double quotes, you see a single quote and then another single quote. So you've got to keep track of your single and double quotes because the SQL statements, when you start to do assignments, are going to want to see quotations. So just be diligent about including single quotes or double quotes. If you're using double quotes for your larger containers, use single quotes for your inner containers. So here there's a double quote that starts and stops this string, and I'm using a single within it. It's a pain to have to keep track of, but it is necessary. Now we're going to create the method for updating or inserting entries. So just before the db_load_entry method declaration, I'll copy and paste new code. So now we have db_write_entry, and I'll go over this line by line. As with the db_load_entry, the first line is a SQL statement. So what we're doing here is we're selecting all columns from the table, icons, where name equals the entry name. So we're selecting a row by entry name and then selecting all of the columns. Now, if you've got a really big data set and it's got a lot of columns, you really just want to select the rows that you need or the columns that you need. I've only got 3 columns, so I'm just selecting them all. And I'm creating an index variable, and this index variable is going to help me to determine if there are rows present or if there are not rows present. So what I'll do is I'll set the index variable to 0, and I'll traverse the rows in the database. Now, if there are rows, I will increment by 1. If they're not, then if I remains 0, that means there are no rows, and so I'll need to insert instead of update. So in the case that there are rows, I will not equal 0, and then I'm going to use an update statement. If there are not rows, then I need to use an insert statement, and they each have different SQL statements that are a little bit differently structured. So in the case that there are not any rows, which in this case there aren't going to be, then I'm going to print some feedback here. And the SQL statement will be insert into the tables, or into the icons table, in the name column and the value column, values, and then I follow the values for the column in order. Let me scroll over. So the value for the name column is here entry.name, and the value for the value column is here entry.value. And don't forget that entry in this case is the object that is fed into dbWriteEntry. And we've yet to call this method, so just keep that in your mind that we're going to be feeding in an object with two properties, name and value. Once we've got this SQL statement down, then we're going to use this method call db::exec SQL. So we're using this method here, exec of the db object, and we're calling this SQL statement. And then we're going to go ahead and print some feedback. In the case where the rows are present and we need to update, the SQL statement here is update the icons table and set the value column equal to entry value, where the name column is equal to the entry name. And then just as we did with the insert statement, we'll call dbExec and we will use the SQL statement. Now we need to actually implement dbWriteEntry into the icon object. To do that, we're going to head down into the new icon constructor and implement it in the +- function. So we'll scroll down to the new icon constructor, find the +- method, which is right here. This +- method is being called by the g.plus and g.minus objects upon touch. So here you can see that on the ended phase, we're calling this method here entry add and entry subtract. If we backtrack to see, well, what do those internal methods do? Adding just takes the value of the object and increments it. Subtracting takes the value of the object, and if the value of the object is greater than 0, then we subtract by 1. If it's not greater than 0, then we just set it to 0. This way, if we continue to press the subtraction button, when it gets to 0, it stops. It doesn't go into negative numbers. I've added a comment here in case you're curious as to how this particular line of code works. I used it earlier too. It's essentially a ternary operator, and it's a lot like writing this conditional statement. I like to use these operators a lot. They're very efficient. Let's head back to +-. And so now outside of this condition where we're checking for adding or subtracting, we're going to paste the following line. We'll call the dbWriteEntry method, and we're going to pass this object here. And this object has two properties, a name property and a value property. And so since we are dealing with a touch event, we can grab the source of the event with e.target. And then it's a child, so we need to step out one level and do .parent, and then grab the name, do the same to grab the value. In this case, e.target.parent is equal to just the root g. Okay, we'll save it, and now let's head to the simulator. Let's clear out the terminal. Okay, so now if I press the plus icon, you can see that in the back, the first time I pressed it, we did this insert statement. The second time, we updated it, and that's because the first time, it didn't exist, so we need to insert that row. The second time, it did exist, so we were just going to update the row. That's going to happen with each of the icons. So now we have inserted 3 more statements based on the icon, so you can see the full SQL statement here. Now, as we increment them, you can see that we have update statements instead. Finally, let's take a look again at the new icon constructor. if you remember, we coded a line g.value equals db load entry, and then you can look at the rest. What this does is that if we reload the application now, since there are entries, the application will have persistence from session to session. What that means is that it's going to load the entries previous. We'll head back to the simulator and let's clear out the terminal. So here, let me increase some values and decrease. So take note, we have 4, 7, 3, and 6. If I close the simulator and then let's go ahead and reload it, you'll notice that we have persistence, 4, 7, 3, and 6. And if you did want to take a look at the database at what's written, do the following. Head to File, Show Project Sandbox, and we'll look at the Documents directory of the Project Sandbox, copy the SQLite file to the desktop. Now let's head to Firefox and go to SQLite Manager, and we'll open from the desktop this SQLite file. Now look at the icons table, and there are the values 4, 7, 3, and 6. If you're not sure how to structure your SQLite statements, you can head to SQLite.org and look at the different commands, and SQLite.org provides these wonderful flowcharts for how to structure your statements. I found it through just Googling SQLite select, update, insert. So let's do update. And I got this really wonderful flowchart that's really easy to follow. Update, and then you have some optional commands. Whatever the table name is, set, and then you can see that there's some iteration. To me, it's really easy to follow. It's a lot like the JSON flowchart, if you've seen that before. But this has pretty much everything you'd need to look at for testing out SQL statements. And if you want to just test out the SQL statements, you can do that within the SQLite Manager. If you go to the Execute SQL portion, you can start to type out your SQL statements. So that way you can test the SQL statements, know that they work, then try to implement them in your code. For a small fee, you can download the project files for this tutorial at cheetomoskeeto.com.